Yeah, I I remember my that's a lot. Exam questions is what's questions are it's just a yeah, it's not your I don't know what question you say. Something's like great doubles. So I totally like I was sitting there for like 10 minutes space. It's like what's the voices like what orders and directions. And then it's since they're rate with doubles, I have I determined it. Well actually I haven't determined yeah, because I was assuming that the reaction order was one because I had I don't know. It's just one piece. It's that. Like two things in this. It's hard to get it done. In my head, I like it. I get to the top. I'll try to. Yeah, this is like that's I try to expect, yeah, I like have to. If I'm not gonna do it over the weekend.
Okay, so if you have any questions, now it's a good time to actually post it on the Slido, okay? Okay, so let's check out some of the questions. Okay, so the first question is like, can we go over question number 6? You mean the question number 6 on the Hangout? Sure. We'll do. So when you say question 6 on the homework or the Hangout, don't know. Everybody has different homework, right?
I don't know how, I don't know.
So what is the question? Though? I need to see the questions. So you have the questions, you have to bring out and let me see, then I can actually go through it. Okay.
It wasn't me who asked it, but
Mhm.
I have my homework here. That's what makes sense. So that might be something to.
Okay. 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 I know these questions. Okay. So it is basically so. Okay, we'll go back to that. Okay, soon. Okay. Second question is actually, if we already have a reserved cast-out time for the test, do we still need to choose a preference date for the next 2 days? Okay. If you are already get the spot that you want, then you don't need to actually do that. Okay. But if you are not getting your first choice, then the second day and the third day give you the chance to actually go to a higher preference date that you want to have. Okay. But if you don't do it, then it won't happen. Okay. I hope that actually answer the question. Is that clear? Everyone understand what I was talking about? Okay. So this, okay, so this is done. Okay, for these questions, okay, so it's the same. Okay, if you get the spot that you want, okay, then you're done with the reservation. Okay, but if you don't get your first choice, you can use the chance in the second or third days to rerun that. Okay, and hopefully you actually go up in your preference to get the date that you want. Okay. Is the way you're teaching now a part of your research? So the things I teach has nothing to do with my research. Okay, but the way I teach sort of similar, right? Because I ask a lot of questions. Okay, so the student in my lab will be bombarded by my questions all the time. Okay, but the things actually like it. Okay, so last year I got the 10 students, 10 undergraduate students come to me and ask me, okay, is it possible to join my research lab to learn to conduct the research in my lab? Okay, so I picked 3 out of 10. Yeah, so we'll talk about like how, if you are interested, then what are the things you need to actually think about it and prepare for it along the way. Okay, so remember last time I posed questions, right? So what are the things that you are interested in, right? So okay, so the first one is actually people want to know about my research, right? I can't give a brief introduction last time. The other 2 things that people are interested in is actually what is PhD program and what is the typical process to apply for a medical school, right? So we will actually give you those information little by little. The semester is actually long. Okay, so the first question I have for you, okay, let's talk about a PhD a little bit. Okay, the first question I actually want to ask you now is actually how much do you think it's going to cost to get a PhD degree in the tier 1 university like UH? Give me some range. Okay, I give you option. Okay, option number one. $10,000. 10,000 is too much. Okay. Okay, $10,000 for 5 years. Second, 20,000. Third, 40,000. Fourth, free. Free. Okay, it is free. Okay, so why it is free? How much do you spend to get? Okay, each credit, how much do you spend? $1,000. Right. It's very expensive, right? So why suddenly you can go from the undergraduate, go to a graduate school, then you don't need to pay anything. You actually get salary for it. Okay, so why that is actually the case? So why that will be the case? It sounds actually contradictory to most people's understanding, right? So the main reason is because what do you do in the graduate school? Huh? TA, research, right? So we keep saying we are a tier 1 university because we do research mainly, right? So what's the point of doing research? Yeah, find new knowledge, right? Provide new knowledge to the world. Okay, so is those things easy? It's very difficult, right? I mean, think about the things you are learning is actually people already know for hundreds of years. Okay, when you do your study, how does it feel? It's okay, right? But it's not very easy. Okay, but this is based on something people already know for 100 years. Okay, you are following the path that the scientists actually provided to you. Okay, so if you compare to the things you're going to do in the PhD, this is way more easier. Make sense? Okay, so how do we actually encourage the smart guys or the guys who actually have really intention to provide new knowledge to do the things that we wanting to do? Yeah, we provide free education for that specific purpose. Okay, is it good? It depends. Okay, so some people will like it, some people will hate it. Okay, so we're going to talk about the pros and cons of getting into a PhD in the following lectures. But today is going to give you some ideas about why some people will like it, some people don't like it. Okay, me personally, I like it a lot. Okay, getting a PhD is actually the things I think I did. I'm very proud I did this. Okay, totally changed my life. Okay, so did I mention that my parents, they're all farmers? Okay, so I was actually from Taiwan, right? Okay, not just Taiwan, but a very small town in Taiwan. Okay, the things I did the most is actually, I grew watermelon when I was young. Okay, the most I spent most of my time when I was young is actually goes into the watermelon farm. Okay, I live in a very beautiful place. Okay, it's actually a mountain around my hometown. Okay, so I spend most of my time actually in the farm. Okay, but no, later on things just got changed. Okay, but in the end, the things that changed me the most is actually I decided to actually study abroad. Okay, getting a PhD in the US. Okay, learning how to do the research, learning how to actually talk to students to deliver the idea, right? So from my perspective, okay, does the things I'm doing now relevant to my research? I guess sort of. I try to deliver the knowledge to people. Okay, so those are the things that's actually similar. Okay, but there's also, of course, a lot of differences. Okay, between teaching and doing research. Okay, but I guess we'll spend more time in the future to discuss these issues. All right, so I guess let's answer for this question. The question we show in the class are way different from the question we got on homework. Why does the homework not show the correct answer when we get it wrong? So starting from last year. Okay, so we switched from Blackboard to Cengage. Okay, so I guess most of you don't have that feeling because you guys are very young. Okay, so once we do that, all the questions are actually redesigned by the Cengage. Okay, but the question I got is actually the accumulated problem that I think is actually relevant to this course. Okay, so they may not be actually similar. Okay, but when you do your quiz, okay, it should be actually very similar to the things you have, things similar to the question that we have here. Okay, pretty much you can actually find all the possible solutions on my handout. Okay, so the quiz actually is the things that matters. Okay, because when you go to CASA taking your exam, right? So I think the quiz is actually the main part of the data bank. All right, so but the homework provided by Cengage is actually helpful because it will actually cover some of the perspective that I did not cover in my lecture. Okay, so like I say in the first lecture, okay, you are not chemistry major. Most of you are not. Okay, I do not expect you actually know every single perspective of chemistry. My job is what? To help you to get the grade that you want. That's the only thing I care. Okay, and then I think that's actually fair, right? Because you're not chemistry major, then why bother? Okay. And some of you actually talk to me, okay? Some of you actually come to my office hour and then ask me some questions. Okay, and then from my response, I hope you realize that I don't really care your background. Okay, I only care what you're actually pursuing. I only care are you actually using the right method to fight for the grade that you want for your future. Okay, that's the only thing I care about. Okay, and then if you talk to me, you should actually see that I do care about you. Okay, so please care about yourself, care about your grade as well. Okay, if you need my help, just email me. I'm responsive. Okay, so don't wait. Okay, if you wait longer, the chances are you're going to drop this class because you won't be able to get the grade that you want. Okay, so if you don't trust me, that's fine. Talk to your classmates who actually talk to me. Okay, they will provide you some insight. All right. There we go. Okay, so if you need to try enough, so it will show you the right way to solve the problem. Okay. Just for your information, okay, the manager of this course actually follows you guys' grade closely. Okay, so after we switch to Cengage, one thing that we see, it has actually profound positive effects for your grade. Okay, and the main reason is because when you do your homework, if you do it enough time, then you can just see how lecture solve the problem. Okay, then you learn those specific concepts that is not covered in my lecture. Okay, collectively, it will make you actually much, much stronger. Okay, so I think that's actually a good design for the student. Okay, so I will strongly encourage you to actually use the Cengage resource as much as you can. But if you are short of time, focus on my hangout, focus on the questions I'm actually solving in the class. Okay, learn the way I read the questions. Okay, that will actually really facilitate you to actually solve the problem a lot easier. Okay, so students have a tendency to overcomplicate things. Okay, I've been seeing this for 7 years. Okay, and I truly believe that it's actually the case. Okay. I guess you also see those things when we solve the problems, right? I only actually focus on very specific things. Okay, if I don't cover it and shows up, I know immediately that it's just something that they're trying to confuse us. Okay, and those are the things I want you to learn. All right. Okay, so I guess that's the answer for this question. What's question number 12? Okay, so I guess I say this last time, okay? Please post the questions that you are not so sure how to solve it on our team side. I check it every day, okay? Then we have to go through and solve those things together. I will tell you actually how I'm going to read the questions. I'm going to tell you what are the keywords, okay? So you can actually associate to the key equation on our Hangout. Then you can just solve those things like a piece of cake. Have I visited any national park? Of course, a ton. Okay, probably actually more than you. All right, so today we're going to go through a few. So we pretty much cover every single concept that you need to actually know for chapter 11. Okay, this week we're going to finish chapter 12. If you haven't actually watched the video, try to watch it before Thursday's back lecture. Okay. The reason we want to actually hurry up and get these things done is because next week, what are we going to do? Review. Okay, so we have a hangout for all those questions covering from chapter 10 to chapter 12, right? So we're going to tell you how to solve those problems so you feel you are more prepared. All right. Today, okay, the first part of today's lecture, we're going to finish chapter 11. Okay, and then I actually select a few more questions. Okay, you don't have it yet, but I guess those are the questions you probably actually encounter when you do your homework and the quiz. All right, so before I go into those questions, any other questions? Okay, so if not, what we're going to do today differently is that we've been doing many questions for chapter 11, right? So today is actually a day. Today will be the first day we are going to invite students onto the stage and solve the problem with us. Okay. You guys thinking, okay, how come these things haven't happened for such a long time, right? Because we lost our first lectures and I can't try to actually get back to the status that I want to be. Okay, but I think we actually finally made it to there. Okay, so we're going to have our first student here. Hopefully he is actually here with us today. Okay, so do we have Hanushka? Are you here? Okay. Are you too shy or you're not here? All right, just let you know, all the things is actually recorded. Just saying. Okay, so we're going to do. Okay, let's do it again then. Ben? Do we have Ben here? No? Gosh. How can I actually improve the attendance rate? Okay, I probably should not say you guys are adults. I don't really care about your attendance. Things in the very beginning now. All right, let's do it again. Hopefully today we got one. Otherwise, I will need some help for volunteers. Yeah, and Tony. Hopefully you are here. And Tony. Yay! Know how to do any of this stuff. Don't worry. We'll teach you. Okay, so Anthony, why don't you actually introduce yourself? Tell us your name, your majors, and what are the things that you like the most?
My name is Anthony. I'm a mechanical engineering major, and I don't like chemistry the most.
All right, so a few things. Okay, so we went through this. I hope that you have this. Okay. Everybody have the hangout, right? So we're going to go back to our hangout. Okay, so everything will have to associate back to this hangout, this single page. Okay, so we're going to go through a few questions that some students actually sent it to me. Okay. Okay, can you read through the questions and tell me how you're going what are the keywords and how you plan to actually approach it?
Consider the reaction 2D plus 3E plus F becomes 2G plus H. When H is increasing at 0.6 mole liters
Per second.
per second, how quickly is E decreasing?
Okay, so what is the keyword?
Let's say I don't know.
Okay, so what this tells you? Okay, when H is increasing at a certain rate, and then how quickly the other thing is actually decreasing. It's talking about what? The rate, right? Okay, so using this magical hangout,
Yes.
okay, how do you actually define the rate when you express the rate in terms of the concentration? So this actually, okay, here, yeah. Okay, so you see this, right? The rate can be written as this. Okay, so that is actually equation. Can you actually write something similar like this based on the equation? Okay, so just want to make sure everybody actually follow. Okay, what are the keywords? Yeah, so you see this actually increase rate or decrease rate of certain species, right? So that is the keyword. So let me flip it so it's easier to write. So stuff from the rate equals to, no, just write out these things because we're going to use this concept. Okay. Okay, so it will be the reactant decrease rate, right? So change of concentration change over time. The change of the concentration of your reactant.
So it's 0.68.
No, not yet. Don't write the number yet. Okay, we want to actually now understand the concept first. Delta. So your species is what? DENF, right? So delta D over delta T. Okay, and then you need to actually divide it by its coefficient, right? So what is the coefficient in front of it?
2.
So it's, yeah, so we might, okay, 1 over 2. Okay, and then because it's actually, yeah, because it's actually reactant, so you need to put the negative sign in the front. Okay, so that's actually for the first 10, right? Can you do it for the second, third, and then the product? It's all the same.
Yeah.
But just divided by the coefficient differently. Okay, you need to put the negative sign if you have reactant. Going for the product. So product will be the same, but it's positive, still divided by the coefficient.
How do you move this stuff over? There you go.
Okay.
Perfect.
Very well. Okay, so this is actually the most important step, actually. Okay, if you see this differential rate law and you see this species change over time, that is actually the things you need to do. Okay, so once you write this out, okay, so let's reread the question again. It says when the H is increasing at 0.6 m per liter per second, what does it mean? No, all you need is actually here. You don't need that anymore. This is all you need. Okay, so you write these equations, right? And then when we read this question, it says when H is increasing at a specific rate, what is the terms it is actually talking about in this equation? H is increasing means
The molarity?
the molarity of H is changing over time, right? So what is that term correspond to? Okay, I give you some options. First, delta D, delta T. Second, delta E, delta T. C, delta F, delta T. Fourth, delta G, delta T, and the very last one, delta H, delta T.
Delta H?
Delta T.
Yep.
Okay, delta H, delta T is going to equals to what? Okay, so delta H, delta T equals to 0.68. Okay, what is it actually asking? What is the question it's asking for?
This one, maybe 1/3 delta E over delta T.
Yeah, there you go. So what does he want to know? It's actually minus 1/3 delta E delta T or just delta E over delta T. What is actually a term is actually looking for?
Delta E.
Delta E over delta T.
Mhm.
Yes. So that is actually a term is looking for, right? So can you use this relationship to figure out what is delta E over delta T?
Yes, I think you have to find the change in time.
Yeah, so can you compute delta E over delta T using the equation you just wrote?
Yeah.
Good. So what would be the answer? Okay, so the decreasing rate of your delta E over delta T is going to equals to,
Negative 2.04.
okay, so the negative means actually is a decreasing, right? Okay, but what you want to report is actually the rate. Okay, the rate will always be positive, right? So you can actually remove the negative side because just to represent it's actually decreasing. Okay, so your answer will be just 2.04, right? So that's how you solve these questions. Okay. Thank you. Well done, okay? Okay, so is this question difficult? No, it's not, right? But why student can actually make it right in the first try? It's because the wording is somewhat over. Right, so that's the things that we need to practice. That's the things that we need to actually go through together so that when you read it for the second time, you know what it means. Okay, I need this to help you. Okay, so if you don't understand certain questions like this, post it onto the channel. Okay, then I can actually collect those things. Then I can actually present to you, tell you how to actually think about these questions. Is that clear? Okay, so this is actually our first questions. Okay, we have a couple. Okay, so today we're going to have a couple students going up here. Okay. This one, we actually have a very similar questions in our Hangout, right? So I would strongly suggest that you go back and check out the videos. Then you will know how to actually solve a question like this. Okay. Your question number 6 is exactly the same like this. Okay, so if you don't know how to do it, really go back to the video recording of last one. Yeah, either the one on Thursday or on Tuesday last week. Okay, we actually went through this one in great details, teach you how to solve it step by step. Okay, so make sure you actually go back and check it out. Okay. Okay, so this one, I want to actually invite some of the students come up here and then help us to actually solve this. All right, there we go. Sorry, man. Is I'm here? No. Iliana? Do you have Iliana here? Yes. Welcome, welcome. Ready? You'll be fine. Okay, don't worry about it. Okay, so introduce yourself. Tell us what you like or what you hate. It's okay. I don't mind that you say chemistry.
My name is Diana Gomez. I'm a biology major and I like reading.
I love biology. Yeah. All right, so we're going to go through these questions. Okay, it's read the questions and tell me what are the keywords you can actually think of. Okay, and then here, there you go. Yeah, and you can try to write on the things. Okay. I have this. Yeah, you are the boss now.
A reaction has a rate constant of 0.0121 seconds. How much of a compound in mole/liters is left after 0.982 minutes if there was 0.706 mole/liters at the start?
Okay, so what is the keyword you will guess?
Say the seconds.
Yeah, very good. So when you think about the keyword, second is actually a good keyword. Okay, the time is a good keyword. So once you see that, then what could you actually think of? What other content you should actually associate on our Hangout?
The integrated recount.
Very good. Okay, so now we only come to this very easy choice. You only have the zeros order, first order, and seconds order, right? So how do you know which one is which? First order, yeah. How do you know it's actually first order?
The S with the exponent.
Okay, so unit of K is going to give you a clue now. Okay, so we know the unit of K is molarity per second for zeros order, right? per second for the first order, per second permeability for the second order, right? It's the information that we have on our Hangout. Okay. C, this Hangout is carefully designed. Very intentionally writing things here. Okay, after 7 years of work, that's what you get. All right, so now we know which equation we need to use. Yes, so write it down. Okay. Okay, so this is the equation we're going to use. All right, so when we read the questions again, can we identify who is who?
The 0.982 is the final.
Okay, let's review the question again. Okay, let's start to assign the number to the equation. Okay, so it says a reaction has a rate constant 0.0121, right? So which symbol in this equation will give you will actually assign to the number?
Time.
So this is actually the rate constant, right? So what is the rate constant in this equation? So the K is what? 0.0121. Okay, so you can just write it down. Okay. How much of compound is left after 0.982 minutes? Okay, so after a certain time, right? So the 0.982 is what? The time, right? So which term? T, right? But the T need to be in second. So how do you do? There you go. Yeah, so write down. Okay.
Do I do the calculations?
We will do the calculation afterwards. So let's just finish the logical flow first. Okay. Okay, so continue. The next one it says if there was 0.706 mole per liter at start. Okay, what is that 0.706 represent? Currently only have two things left, right? One is actually AT, one is actually A0. So what is left turn? 0.706 M.
Is it the A0?
Yes, because how do you know it's actually A0?
Because it says at the start.
Yeah, at the start, right? So you know your A0 is 0.706, right? Going to write the natural log and then 0.706. Okay, so from this writing, you can see that you know everything on the right hand side, right? The things on the left hand side is the things you are solving for, right? So what is your AT? It's actually a concentration of A after let's just let 0.982 minutes, right? So that is actually the things you're actually looking for, right? So you want to solve for your AT, right? So how do you do that? How do you actually solve for your AT? Of course, let's say you actually can solve all these things. Have the pencil. Okay, so if you do all these calculations, okay, so it is negative 1.06. Okay. Okay. So after here, right, you have natural log A equals to a number, right? So to remove the natural log, what do you do? you took the exponential on both sides, right? So once you do that, then on the left-hand side, you become a times t is going to equals to exponent minus 1.06. Okay, and then this will give you a number of 3.46 times 10 to the negative 1. And that is actually the things you're looking for. Okay. All right. Thank you. Okay. Yeah. I hope it's actually not. Is this difficult? Once you see the keyword, once you know what equation to use, once you can actually assign a value to your equation, things become very straightforward, right? Okay. The problem is actually, can you actually go start from the first step? Okay, that first step is actually said it's going to take the longest. Right. So how do you know go to the equation? Is the things you need to actually practice a lot. All right. Okay, so this is actually the equation that I want to invite students, but I want to actually go to another one. Very small one. Okay, but another one that is actually relevant. Okay, so I just go through this one quickly so that you can just see what the difference is here. Okay, so in this specific question, it says if a first order decomposition, how long does it take of 11.44% of the compound to decompose? Even the rate constant is actually 0.0749 per second. Okay, so what are the keywords here? First order is 1. What else? How long does it take is what? Time, right? So you know to use integrated rate law, right? Therefore, you know the equation to use is natural log A t equals to negative kt plus natural log A0, right? So that's how you should get started. Okay, nothing is special, it's all the same. Okay, now, okay, go on. Everybody follow. If I'm going too fast, also let me know. Okay. So now I want to actually start to assign the number from the question to the equations, right? The things that's easy to assign is the k, right? It tells you is 0.0749 per second. Okay. T is the things that you are solving for. Okay. And then it tells you how long does it take for that many of compound to decompose. This is actually tricky part. This is actually a part that many students will get it wrong. Okay, so what does this tell you? The first question I want to ask you is actually, is this your AT or A0? AT. Okay. It's related to your AT, but not your AT. Okay. What's your A0? 100%, right? Okay, so you know your A0. I hope you see this. And it is the most important thing that you want to actually see for this question. Okay. So your A0 is 100%, meaning the nature log A0 is going to equals to nature log 100% is just 1, right? What is nature log 1? Nature log 1 is simply equals to 0. Okay. So you know this term is going to become 0. Okay. And from the question, so far so good. Okay, so if you don't know this, okay, just memorize it. It's a mathematical fact that nature log 1 is going to equal to 0. Okay, Or you can actually operate on your calculator. It will give you the same number. Okay, so now, what are the things we are looking for? Are we looking for A, T, or T? T, right? Because it's asking for how long, right? So T is actually the things that we want to know. That means we need to actually provide a value to our AT term, right? So what is your AT? Yeah, so what's the number you should put into for your AT? Okay. There you go. Okay, so it says the AT, okay, the final answer will be 88.54%, right? Okay, so the AT is actually the remaining A at time T. Okay, so in the questions, okay, I want to read it very carefully now. What it says is actually, how long does it take for that many of compound to decompose? Okay, it did not say how many remain. Okay, this one to actually contrast to the previous question. Right, in the previous question, we don't use the numbers because in the previous question it says use this word remains or left, right? Meaning the concentration of less specific at less specific time. Okay, but in this second question, it says, I want to have 11.44% decomposed. Okay, that means you still only have 88.56% remains or 88.56% left. Okay, so this is actually a part that, stop you from getting the perfect score. Okay, so you want to actually make sure you recognize the keyword clearly. Okay, it has to be either left, remain, then you can directly use those numbers for your AT. Otherwise, if you see the keyword like decomposed, okay, then it should be the flip side of the number need to be input for your AT. Is that clear? Everybody follow this? If you don't, it's fine. We can go through this again, but let me know if you don't. Yes, so if the question was that, how long does it take for 11.44% of compound remains, then you input 11.44% for your AT. Okay, so you need to actually see the differences here. Okay, that is actually the trick that I'm going to play. All right. Any questions for this? Okay, so if not, then I want to go through this question. I think this, yes. This is equals to 0.8856. Yeah, I just try to read the percent. Okay. Okay, so this is actually a very interesting question. All right. So this is about the elementary step and the reaction mechanism. Okay. The things we discussed so far, remember, every time we want to actually determine who is actually rate limiting step, we have these three steps, right? First is actually you need to add all the equation up, identify who is actually reactant, who is actually product. Okay. This question is somewhat on the derivation of the concept. Okay. So it gives you a mechanism involve three steps and asks you who are the reactants, who are the products. And here you can see, it also asks you who are the intermediate, who are the catalyst. Okay, so how do you actually assign the role of every single component? is the things I want to discuss here. Okay, so how do you figure it out? Again, you add up all three steps, right? The things that remains on the left-hand side is your reactant. On the right-hand side is your product. Okay, so let's do that first. So from here, you can see you have something repeat here and here, right? This and this will cancel out, right? Anything else? How do you think? It does. Yeah. Anything else will cancel out? Okay. Where is HI? I don't see it. HIO. HIO will cancel out. Right? Anything else? That's all right. It's other things you're going to repeat, right? So if you're adding up on the left-hand side, you are going to have ClO minus plus I minus. That's going to give you HIO plus Cl minus. No, sorry, my bad. That's all right. Okay, so it's very easy for you to assign the reactant, right? So this will be product, right? So far, so good. Okay, now I have a question for you. What are the intermediates? Okay, so this is actually part I did not really cover fully. Okay. So for the intermediate, okay, meaning you need to first form in the on the product side, then they got cancel out. Okay, those things will be intermediate, right? So what other things is actually first formed on the right-hand side and later on got disappeared? Okay, there will be your HClO, right? Your OH minus. And then HIO, right? Yes. The intermediate sexual species, they got canceled out and it first appeared on the right-hand side of the equation. Okay? Everybody follow the things I just said? Okay, so if you look at this, the species that fulfill the requirement is actually HClO, OH minus, and HIO, right? That's actually one thing to not fulfill the requirement, right? Why is that? The water, right? So what is water? What can catalysts do? Affects what? Activation energy, right? And the activation energy will actually represent is associated with your rate constant K, right? So that's actually some concept you also need to have in mind. Okay, but here that's not the things we're discussing here, right? The things we're discussing here is actually first, can you actually know the way to identify your reactant product? Okay. Second, you should know the differences between. You should know the definition of intermediate. Intermediate are the species that got canceled out after they add all these elementary steps. And also, it must first show up on the product side, right? So that we can call it as intermediate. Okay. H2O in this case show up on where? On the reactant side in the first step, right? Even though it later on got canceled out, that means it doesn't involve in this reaction. Right? Yeah. So why you still write actually on the elementary step because it is a necessary thing. Okay, since it actually first appear on your reactant side, that means its role is not intermediate. Instead, it is actually a catalyst. Let's speed up all these things. Okay, so this is actually something that you're going to encounter, I believe, in your quiz. Okay, or maybe in your exam. Okay, then you should actually have a good idea. All right. Typically, yes. Yeah. So when you write out this elementary step, it's actually you want to actually really spell out, okay, what are the things that's going to involve in every single step. Okay. So when you write the overall reaction, this is actually what you write. Right? You only write your reactant, you only write your product, right? This is actually what you are talking about. Right? You write H2O on top of that arrow. Okay, so let's actually normal way to write it. Okay, but here is because you are writing the elementary step, so it is somewhat different from the overall reaction. Does that make sense? Okay, so any other questions? Okay, cool. So, okay, I guess that's actually all the things I want to cover today for chapter 11. Okay, I really want to actually enter chapter 12. Okay, so chapter 12 actually doesn't have too much to actually talk about. Okay, so these are the 4 most important concepts that we need to actually memorize. Okay, so for today, I hope we can finish the section 1. Okay, if possible, go to section 2. So the section 1 is actually going to learn the things called the chemical quotient, Q. Okay, so Q is actually defined as if you have a chemical reaction like this, AA plus BB give you CC plus BD, where capital A and B is your reactant, capital C and D is your product, and the lowercase a, b, c, d is just the stoichiometry coefficient of each individual component. Okay, then you can always define a term called a chemical quotient. Typically, you have this symbol Q. It is defined as the product of your product to the associate exponent divided by the product of your reactant to the associate coefficient. Okay. These things, do these things look familiar to you? So what do we use this before? We use this one. We use this thing called the equilibrium concept, right? Yeah. So the way the mathematical expression of your Q and K are exactly the same. Okay. But your K is a constant, right? The K is a constant. Okay. So why the K is a constant? Because it already reached equilibrium. Right? It means the concentration of your reactant product don't change anymore. Right? Since the concentration is not changing, the exponent is not changing, therefore you got a constant. Okay, that is actually the status where your reaction want to go. Your reaction always want to reach equilibrium. Okay, but when you just throw in, when you just initiate a reaction, meaning in your container you only have your reactant, you don't have any product. You can still do the same calculations, right? Then you know your Q is going to be equals to 0, right? Because you don't have any product. Okay, so you can calculate your Q at any given time. Okay, so you can calculate at 0 seconds, 1 second, 2 seconds, 100 seconds, 1,000 seconds. Okay, so because as the reaction goes by, the concentration of your reactant product, they all changes, right? So from that sense, you can see your Q is actually not a constant. It is a value, it is a quotient that's going to change over time. Okay, so the direction your Q is going to change can be predicted by when you compare your chemical quotient and the equilibrium constant K. Okay, you can see your numerator is what? The product of your product, right? So if your Q is larger than K, it means you have too much product compared to the product you have at equilibrium. Everybody follow the things I just said? Okay, so if your Q is larger than your K, meaning you have more product than the product that you should have at equilibrium. Okay, then what does the reaction do? It's going to move to the reacting side so you can minimize the amount of product that you have so that you can reach equilibrium. Okay, so if your Q is larger than K, it means you have too much product. The reaction will actually move to the reactant side. Okay. In contrast, if your Q is smaller than your K, that means you don't have enough. So you want to move to the product side. Okay. So the first concept of this chapter is that do you understand the meaning of Q? Okay. And then based on the comparison from your Q and K, can you predict the direction that the reaction is going to move toward? Okay, so that is actually the first big thing that you need to actually learn for today's lecture for chapter 12. Yes.
That there is too much product to move to the reactant, and then this will move to the product. Is that too little reactant or too much reactant?
So if Q is smaller than K, so better to actually just pick one perspective. Don't mix reactant and product. Consider it at the same time will confuse you. Okay, I would suggest thinking from the product side. Okay, so this is actually the first questions that first concept that we need to know. Okay, and then the other things that we need to know is that here, even though I express the concentration, we use the concentration to define your Q, right? Sometimes you actually use the pressure to define the Q. Okay, so your Q can be expressed as the pressure of your product over the pressure of your reactant. Okay, so if your species, they are all in the gas form, many times you actually express your equilibrium constant using a pressure instead of concentration. Okay, but they actually represent the same reaction. Okay, that means we actually call these things as QP. Okay, this is QC. When you reach equilibrium, then you're going to have the KC and KP. Okay, so every time you see this capital italic K, that is actually the equilibrium constant. Okay, the subscript represents actually you express in terms of concentration or in terms of pressure. Okay, KP and KC is exchangeable. Okay, so they actually associate with each other through this simple equation. Okay, so the Kp is going to equal to your Kc times Rt raised to the delta nth power, where your delta n is the coefficient differences between your product and the reactant in the gas phase. Okay, so we're going to go through these things later on when we go to the questions. Okay, but this is actually pretty much the concept that I want you to know for the first part. Any questions? if Q is smaller than K, you have two less product. Yeah. So I think thinking from the product perspective will avoid a lot of confusion. Okay, so if Q is small, that means you have two less product. Okay, if Q is big, means you have too much product. Okay. All right, so if let's actually questions. Okay, let's read through this. Consider the gas-phase reaction CO2 plus Br2 will give you 2 BrCl, for which Kp is 32 at 500 K. So when you see this Kp is 32 at 500 K, that is actually the equilibrium constant K, not Q, right? It's equilibrium constant K. If the mixture is analyzed and found that contains 0.49 bar of CO2, 0.29 bar of Br2, 2.1 bar of BrCl, describe the situation. Okay, so one unique feature of this question is that it's going to give you the concentration or pressures of your reactant product directly. Right? So again, your reactant. And then your product is this. And it gives you the concentration or the pressure of each individual component. Okay? Every time you see that feature, it is an indication to tell you to calculate the Q. Okay? If you have the concentration or pressure of every single individual species for your reaction, meaning it asks you to calculate the Q. Okay, so this is actually a very important feature for you to calculate your Q. Okay, so once you see that, then you know your Q is going to equals to the product is 2.1 bar raised to the second power. Reactant is 0.49 to the first power, 0.29 to the first power. Okay, so this is actually how you calculate your Q. Okay. So once you do a calculation, okay, so once you do the calculation, you should get a number of 30.95. Okay, so once you get your Q, and you also provide a K, right? That means you also should compare your Q and K. Your Q is 30.95. Your K is 32, right? So your Q is less than your K, right? Meaning you don't have enough product, right? So the reaction will move toward the product side. Okay, so let us actually how you actually solve this problem. Okay, so the key here is what? Key here is that when you see the concentration or pressure of individual element for a specific chemical reaction, it's a good indication that you need to calculate the Q. So in this case, this is a Kp, right? The things you calculate is actually Qp, right? So how do I know it's actually Qp? Yeah, because giving pressure. Okay, so the quantity you calculate is actually Qp. Okay, so you want to compare Qp to Kp, Qc to Kc. Okay. But again, the really important thing here is actually when you see the questions, right? Can you recognize that you have all the information you need for each individual component? If you do, then you know the thing to do right away is to compute your Q, right? So you can just compare to your K, then you will know where the reaction is going to move. Okay, so that is actually a concept that we should actually have. All right, any other question? Yes. Maybe louder, I cannot hear you. So no, so you're asking for what is the main keywords here, right? The main keyword is actually the individual info, the concentration operation of individual component. Okay, that is actually the keyword that you know need to calculate your Q. Okay, and once you calculate your Q, the question that's going to associate with is actually going to compare your Q and K. Okay, and predict where the reaction is going to move. All right. So we only have 5 more minutes. Okay, so I guess I won't go through more content today. Okay, so let's talk about something else that you are interested in. Okay, so if you want to actually add through Slido, that is fine. If you want to just shout it out, that is actually fine too. So do you have any other questions? How big is what? My research group? On my hometown? Maybe 3,000 to 5,000 at the most. Yeah. Yeah. Okay, let's go. Okay. Okay, so let me give you a few words about, I think I want to actually continue the things we discussed in the very beginning of the lecture. Okay. PhD program. What's the best benefit of PhD getting a PhD? Huh? Getting paid? Yes. Okay, so what's the difference between bachelor, master, and PhD? 8 years. No, not in terms of time. Not in terms of time, in terms of salary. I guess that things that look here about.
People that with a bachelor's degree, I don't think they'll ever get tenure. Like, you know what I'm saying? Like, I mean, I guess you could go to like, I mean, academia was your goal or something, but what I'm trying to say is people with the PhD tend to earn higher, they get that like project lead, like, doctor.
Okay, let me give you a quick summary about the difference between bachelor, master, and PhD. What's the best benefit of PhD from the salary perspective? Okay, so whatever what you do in the future, if you want to go to industry, that is fine. Okay, when you go to industry, okay, you get a salary boost, right? You start earning your first salary. Okay, when you do your bachelor degree or master degree, there is always a salary cap associated with it. Okay, so if you think about it as long term, let's say you enter the industry early. Okay, of course, your financial situation will improve quite well. Okay, so even with a bachelor degree, you can earn a reasonably good salary. Okay, but because you only have bachelor degree, okay, your salary actually have a cap. That means, okay, you jump up first quickly, right? And then every year your salary will increase incrementally. Okay, and very quickly you're going to reach your cap. Okay, and then you may need to actually live with that salary with cap for the rest of your life. If you don't make any changes. Okay, so that cap is actually depending on the field you are interested in. Okay, it's going to vary. Okay, but don't expect too much. Okay, so the difference between your bachelor and master is actually the initial salary will have some differences. The cap will have some differences, but you're going to reach your cap pretty quickly. Okay, so PhD, you don't have that cap. Okay, and the main reason is because PhD is actually the highest possible degree you can earn on the earth, right? So they cannot use you don't have the degree as an excuse to prevent you from actually, have some boost for your salary. Okay, so that is actually a very practical point. Okay, of course, the downside is what? The downside, of course, is difficult. Okay, so let's talk about the salary first. Okay, focus on the salary perspective is that you need to spend, depending on your major, okay, 4 to 5 years to get your PhD. Okay, so are you actually allowed to do so financially? Will be actually something you want to consider, right? So, but we also mentioned that if you go to the research university, okay, you are financially supported. Okay, I realize actually many kids, they think it's going to actually cost you a lot to get a PhD. No, it won't. Okay, so financially, okay, PhD is actually has great benefit. Okay, so if you have some intention they want to actually go through PhD and you're worried about the financial problem, it shouldn't be there. Okay, but there are actually many other things you want to consider if you want to pursue a PhD afterwards. Okay, so we're going to talk about what other things you want to consider before you make your final decision. Okay, so I think that's all for today. Thank you.
Is there any way like we can update whenever we're not gonna do like the thing that you portray on the team?